All right, here's an example where we could put the discriminant to use. If you were asked something like show how many solutions a quadratic has, or show why this is the number of solutions that a quadratic graph has, you would use the discriminant. So remember, our formula is b squared minus 4ac. Basically all we need to do is determine the a, b, and c values and then replace them into this formula and calculate. Pretty simple. All right, so if we were given this equation here, b is 16, so I'm going to take 16 and square it, and then subtract 4 multiplied times a, which is 1, and c, which is 64. You can literally just type this into the calculator as it is, so 16 squared minus 4 times 1 times 64. Don't really need to include the 1, but I thought I would. And we come up with 0. Remember, if our discriminant is 0, that means that this graph would have one solution. So there would be one location where this graph would touch the x-axis. Okay, I might come to the side and kind of show you. And kind of show you. So if I had this x squared plus 16 x plus 64, if I factorize this, it would break down to look something like this: x plus 8 times x plus 8. So we'd come up with just one solution, right, of x equals -8, so that matches, right? One solution is what we have in that occurrence up there, okay? In example 2, I have a new equation, so I have b squared minus 4ac again. My b value is positive 4, and then I'm subtracting 4 times a, which is 1, times c, which is 10. I can already tell 16 minus 40, that's going to give us something negative. Is it negative 24? So since we have a negative number, that means I have no solution. Imagine, remember I said this bit comes from underneath the square root of the quadratic formula. So if you were trying to take the square root of this, if you're using the quadratic formula to solve this, you would not be able to take the square root of 24. So that would be an issue, and we would have no solution when we were calculating that out. So if you ever do get to a situation where you are using the quadratic formula and whatever you have underneath the square root is negative, you would just write your answer as no solution, and your quadratic graph would look something like this, floating above the x-axis. Okay, so no solution, that's acceptable. If you do take maths at A levels, you'll learn more about these, but we call them imaginary numbers. If you take the square root of a negative number, that's for another day, but just kind of thought I would mention that. All right, the last example, again using b squared minus 4ac. Let's see, my b value is -7, so I have -7 squared minus 4 times a, which is 1, times c, which is 10. So this becomes 49 minus 40, gives me a positive 9. Okay, remember, if I have a positive answer, doesn't matter what number that is, I know that I have two solutions, which means that my graph would cross the x-axis twice. All right, and if we factorize this, right, if I wanted to show you x squared minus 7x plus 10, if I factorize that, I come up with this. And if I solve, setting equal to 0, if I solve, I do get two different values, okay? So that means that these are the two locations. I know that's not perfect, but those are the two locations where we cross the graph. All right, remember, it doesn't really matter exactly what value you have, if it's positive or if it's negative. You just need to look at, is it negative or is it positive, to tell you how many solutions that you do have when you are using the discriminant.